does it offload the situation? Awesome. So still minimum 4, maximum 5. Sorry, I did my best. Yeah. What else could I say? No. Your welfare is being covered by Mr. Ameniwa, right? Oh, okay. I hope I didn't make a mess by mixing it up. Okay, anyway, 13.2 homework. Okay. The homework questions were question 4, 5, 8, 9. Good afternoon. 12 and 13, right? Am I right? Okay. Any questions regarding 4? Question 4? Question 5? Okay. Question 8? 8? 9? 9, okay. 12? Wow, 13? Okay, looks like for everything. Okay, let's see. Question 5. Question 5. I believe if I do increasing, that means you all can do decreasing. Right? Okay, so fx is given to be this. So the differentiation of it will be 4x plus 1 to the power of 3 times 1. Okay, which will be 4x plus 3 cubed. Right? Then we want to find the intervals where fx is increasing. So we want to find the values of x such that fx is increasing. So if fx is increasing, that means f prime x has to be more than 0, right? Then that will mean that 4 times x plus 3 cubed is more than 0. Okay, so 4 is clearly a positive number. It needs to multiply by a positive number in order to give us everything to be more than 0. So x plus 3 cubed has to be more than 0. Okay? In order for x plus 3 cubed to be more than 0, our x plus 3 has to be more than 0. Okay, if you think about it, for example, 2 cubed will be equals to 8. That gives us something to be more than 0. If our base itself, let's say negative 2, okay, yeah. Why? Oh, sorry. Okay, so negative 2 cubed itself will give us negative 8. That gives us less than 0. So the base number itself, it has to be positive in order to generate the entire thing to be positive. If the base itself is negative, then the whole thing will be negative. So in this case, our base to the power of 3, okay, in order to be positive, our x plus 1, the base must actually be a positive number, right? So that means that x must be more than negative 1 in order for fx to be increasing. Okay? So we just do the similar thing, alright, when it comes to decreasing, whereby the inequality here is negative. Okay? And then that means that for conclusion, in order to be decreasing, x will have to be less than negative 1. Okay? So that should be the answer for part 2. Any questions? Alright. Next, question 8. Okay, given this for x less than 0, we want to find dy over dx and explain why y is an increasing function. So if we were to differentiate this using our quotient rule, keep the bottom differentiate the top, minus away, keep the top, differentiate the bottom. And we can simplify this, we get 6x power 4 plus 6x squared minus 4x power 4. So 2x power 4 plus 6x squared over x squared plus 1 squared. Right? Am I right? Question 8. Okay. So now we want to explain why y is an increasing function. Okay, so the aim okay. So when you do your differentiation dy over dx, you can give your answer like this, okay, as per what the question wants, to get dy over dx. You could also, okay, choose to factorize in the numerator. That is perfectly fine as well, in order to get this. Okay. So to explain why y is an increasing function, we need to justify how is it that our dy over dx is more than 0. Okay. So essentially, we want to justify how dy over dx is more than 0 always. Or in this case, sorry, for x less than 0, because the question says for x less than 0. Okay. So looking at the derivative, where we have 2x squared plus 3 over x squared plus 1 squared. Okay, we recognize that there are 3 parts into this derivative. One part is 2x squared, the other part x squared plus 3, the other part over here. Okay, so with the given interval for x less than 0, looking at the first part of this fraction, 2x squared, okay, will it always be positive? What do you think? It should always be positive, right? Okay, because x squared will always give us a positive number. In this case, it's not possible to be 0 because x cannot be equal to 0 in the first place. Right? So 2x squared, we know that it's positive. Then we look at x squared plus 3. Okay, x squared plus 3 has this x squared in it. X squared itself is always more than 0. Okay, so x squared plus 3 will be more than 3. Will be more than 0. Okay, so first part, second part done. Next part, it is about the denominator. Denominator itself, likewise, is entire thing squared. Okay, it will always be more than 0. So we see that 2x squared plus 3 more than 0, x squared plus 3 more than 0, x squared plus 1 squared more than 0. Putting them together, okay, multiply, divide and all that, it will surely still be a positive number. Okay, so that's how you could explain why y is an increasing function. Okay. Could I understand what is the challenge in terms of question 8? What was the difficulty faced in question 8? Is it about piecing it together? So, but for when you understand these parts, right? Are you able to arrive at this idea? No. Is it because you left your answer at this? For dy over dx? You got it like that? But you don't know how to move from here to here. Okay? What about the rest? Able to do? Is it? Okay. So next one, question 9. Okay, we want to find dy over dx. So do product rule. Find the dy of dx, and then we want to determine the range of values of x for which y is decreasing. So for y to be decreasing, our dy over dx has to be lesser than 0. It is going to be difficult to decipher that if I leave my derivation in this form. Okay, what will be easier to handle is if you factorize instead. Okay, there is nothing wrong if you leave your answer like that to answer the question about dy over dx. But to help you to actually understand what is the range of values of x, this will actually be difficult to manage. So in this case, we factorize out 2 and then also x minus 9 squared. So we will be left with 3x plus x minus 9. Okay. So this simplifies to this 3x plus x, 4x minus 9. Okay, so we have it like this, then we see that it's just a direct product of things. Okay, rather than if you were to see it in plus, because when we have plus and minus, okay, to decide how is it that is going to be lesser than 0, there's too wide a combination that we can have. Because in order to arrive at less than 0, right, let's say I want to have 3 minus 4, I'm going to get negative 1 that's less than 0. But I could also have things like maybe negative 1 minus over 3. That will give me less than 0. Okay? I could also have negative 1 plus negative 4, something like that. Just too many combinations, okay, if we have to deal with plus and minus. Right? So it's very difficult to limit our consideration, our cases. Okay, so to actually help ourselves, is it actually better if we can have product of things or maybe in a fraction itself like that. Right? So using this one, in order for it to be decreasing, we understand that 2 itself is positive, x minus 9 squared is always positive as well. So in order for the entire thing to be negative, there's only one possibility, which is that 4x minus 9 must be negative number. Okay, so we got to write that out. Okay, so since 2 more than 0 and x minus 9 squared more than equals to 0 for all values, all real values of x, then 4x minus 9 has got to be the one that is lesser than 0. Okay, so 4x less than 9, x less than 9 over 4. Okay, so the answer will be x less than 9 over 4. You could write it as mixed number, 2 1/4, that's also fine. Next one, question 12. Okay, so yeah. Okay, so question 12. In order to show that R is always increasing, what exactly is it that you must have at the end? X is more than 0. You want to show that R is always increasing. dr over dx, yes. Okay, the derivative is more than 0, right? So at the end, you want to have your dr over dx. Be very careful, we're talking about r over here. So dr over dx, we want to show that it's more than 0. So we do our differentiation. In this case, 0.05 times 2 is 0.1. Okay. So 0.1x plus 8. In this case, what is x again? X is the sale of, dollars be the revenue from the sale of X textbook. Okay, so we're talking about X textbooks, right? That is the definition in the question. X is given to be the number of textbooks. Number of textbooks, can it be negative? No, right? So number of textbooks can only be positive. So 0.1 times positive number surely is positive. Plus another 8, it will surely be positive. That's why the r over dx is always more than 0. Okay? So we write that since x is the number of textbooks, then x is more than 0. So 0.1x plus 8 is more than 0. Therefore, the r over dx more than 0 and r is always increasing. Okay? Okay, last one, question 13. I am guessing that question 13, the challenge is in part 2. Am I right to say that? Okay, part I. Alright, so let's see. Okay, question gave you the period T of a pendulum where L is its length, and they said that G is the acceleration due to gravity. But more importantly, the question says that G is a constant. That means that G is a fixed number, it doesn't change. Okay? We want to find dt over dl. So I can rewrite T to be 2 pi times L over G to the power of half. Recognize G like a number itself, like how you see pi as a number. So to do dt over dg, so maybe it may help if you want to write it like that. Okay, 1 over gl. So the variables in the question is t and l. So dt over dl will be 2 pi, chain rule, bring down the power half, keep 1 over gl, half minus 1, that is negative half. Differentiate inside, because this is a constant number, like half L, or 1/4 L, that kind. So half L differentiate, you will get 1 over G. You understand? Okay. Then simplify, we have pi and pi over G, and then L over G to the power negative half. So that is pi over G, G over L, half. So that's like square root. Hang on, let me. Square root G over L. Okay, the negative causes the fraction to flip. Right, your negative index, the negative applies to the whole fraction here because of the brackets. So L and G can flip to become G over L. The half is a square root. So my answer, if I want to write it in radical form, will be pi over G, square root G over L. Okay? What does the sign tell you about? Oh, but then, let's see. G squared Okay, are you concerned that this one doesn't match your answer key's answer? Okay, so how to from here get your answer key's answer, right? It is a matter of your cert form, but it's okay if you leave your answer like that, not an issue. It's actually the same. So pi over g square root g over L. Okay, you bring in the g into the square root, so that means g square L over g. So pi square root cancel 1 over GL. So that's how you get the answer in your answer key. Square root 1 is 1, so you get. Okay, it is just like your numbers when we saw 2 square root 2. It is the same as 2 bring inside will be 2 square times 2. So therefore it is square root 8. Remember your certs? Okay? Right? Or maybe instead of having too many 2's, it's just change it to 3. 4 times 3, 12. Okay? Clear? Right? So you could leave your answer like this, not an issue at all. Okay? Then the next question is asking about the sign of dt over dl and what is the result? What does the result tell you about the period of the pendulum? Okay, so we need to figure out what is the period, what is the sign first. So since g is a constant, okay, it is actually a more than 0 value. Let's see. This question didn't say. Okay, in physics wise, okay, how many of you take physics? You know what's the value of g, right? 10, you don't know. You don't take physics. You take physics and don't know the value of g. G is 10. Yeah. Okay, at secondary school level is 10, right? You go up, then you count 9.1. So g is actually the acceleration due to gravity, right? So that is 10 meter per second square. Okay, and actually to improve the question, they should have specified that g is actually more than 0. Okay, so if you know that g is more than 0, and since L is actually a length itself, length must surely always be positive. So g and L are actually always positive. Okay, so pi is surely also a positive number. So pi positive, g positive, L positive, whole number here will be positive. Okay, so whole number is positive, right? What does that mean? That means that your dt over dl is increasing. It's positive. Okay, so dt over dl is positive, therefore your t itself is increasing. So the period of the pendulum is increasing. Okay, so let me write that down. Okay, since g is more than 0 and L is more than 0, dt over dl, which is whichever form that you choose to have, you won't be able to deduce that dt over dl is more than 0. Okay, since your differentiation, your derivative is more than 0, that means that t is an increasing function. Okay, take note that it is t that is increasing, not dt over dl is decreasing. dt over dl just justifies that t is increasing. So in the context, the period of the pendulum is increasing over time. Is increasing. Just say that. Okay, that's all. So, okay. Cycle. Okay, any questions? For many students, have you all done experiment with the pendulum before? So it makes sense, right? Because when the length of the pendulum is longer, your period, that means one cycle of the oscillation is longer, right? Okay, So that's all. Alright, could you submit your homework to the front? Okay. 6, 1, 2, 3, 4, 5, 6, 7, 8 because 1 and 2. Okay. Yeah. Why you want to class? It's not product. Because if you want product, you keep the 2 high, you differentiate this, which is what you got here. But if you keep this, right? If you keep this, you differentiate 2 pi. 2 pi is a number, it's a constant, it's a 4. Differentiate 4, 0. So differentiate 2 pi is 0. Right, so actually don't have this one. Yeah, if this one will L, then you will have 2 pi. 2 pi is this is half of L. Okay. Yeah, I just sound you will not affect it.
Yeah. Just now you got 5. Yeah.
Okay, we will finish up our 13.4 today. Amanda, leave it on my desk later. Okay. I think we only have time to finish up our 13.4 today.
How many pages like that?
How many pages? Let's look at try 10. Okay, in try 10 you are given a probably better diagram than what I can draw, okay, on the whiteboard. Alright, so it says that there is a boat being pulled to the dock, okay, by a rope attached to a pulley, right, on the dock. The dock is where the boat will end up arriving at. Okay, it says that the vertical distance, vertical means in this direction, it is 3 meters. Okay, vertical distance between the pulley to the boat itself. Right? Then and it is 3 meters. If the rope is actually being shortened, okay, so that means that your rope is going to be pulled in this direction, okay, being shortened at a rate of 0.75 meter per second. Okay, the question asks how fast is the boat moving when the boat is 7.5 meters from the dock. So that means we are looking at the horizontal distance of 7.5 meters. Okay, we want to know how fast is the boat moving. So meaning to say in this direction, we want to know the speed, right? Okay, so let's give some variables so that we can figure out how our chain rule is going to be used. Right, so let's define x. Let x be the length of the rope, and y, or rather x meters, and y meters be the horizontal distance So I define these variables in this manner because the question gave us the speed that the rope is actually being shortened, okay, which is in this direction, right? So we need something that is over dt, okay, d something over dt, right? And then we are also given this distance over here. Okay, so we need to, in fact, we need to find out what is this speed over here, which is something again over dt. Okay, so with the given information, I give a variable so that I can, instead of writing question mark, okay, I can write in this case dx over dt and dy over dt. Okay, so that is the reason why, alright, I define these variables and nothing else. Okay. Right, so we want to have dy over dt when y is equals to 7.5 and given that dx over dt is 0.75. Okay? So whenever you have such questions, the challenge is to first recognize what is the information that you have. Okay? Then after that you can figure out that statement, that equation, before you fill up all the blank spaces. Okay? So with all the dt's already, we need something that is dy over dx. Okay, so we need to have 2 dt's and then after that, one of it, which is dy over dx. You understand? Remember? Okay, so our statement will be dy over dt equals to dy over dx times dx over dt. And this is what we want to find. Okay. So now, okay, how am I going to get my dy over dx? I need to have my y and x, the equation in the first place. Okay. So if this length, right, were to be my y value, so we use just this color, because I define y to be the horizontal distance between the pulley and the boat. Okay, pulley is here, boat is here. So this is the horizontal distance. Okay, and if I were to see my x to be the length of the rope, which is this part here, okay, let's just imagine that this boat is like a point, okay, we ignore the fact that the boat has some height to it, okay, so essentially we are looking at a right angle triangle, assuming that this dot itself is perpendicular to the water edge. Okay, so this is my y, this is my rope x. Okay, and this vertical distance, we are told that it is 3 meters. Okay, so we got a right angle triangle going on. Right, and that's where we can use Pythagoras theorem. And Pythagoras theorem tells us that x squared equals to y squared plus 3 squared. Okay. Since we want dy over dx, let's make y squared the subject. We cannot differentiate with y squared itself. We must have y. So y is equals to square root x squared minus 9. Okay. We actually reject the negative 1 because y is a length. Okay, so just let you know. Right, so we are looking at y equals to square root x squared minus 9. Okay, so dy over dx, differentiate this one. and we get this. Okay, so with this, then we have our dx over dt, which is given to be 0.75. Okay, since our rope is being retracted, right? Okay, being reduced in length. Okay, we recognize that we take decreasing as negative and increasing as positive. So our dx over dt is actually negative 0.5. So our dy over dt will be as such. Okay. We want our dy over dt at a certain value of y. So when y is equals to 7.5, we need to figure out what is x. Our x squared our x is 8.0777. So dy over dt and 3SF, that would be 0.8 negative. Therefore, we get that our boat is moving back to the dock. So this idea of being back to the dock is representative of the negative sign. That's why over here, we no longer talk about negative 0.808. Negative 0.80, yes. Okay? Questions? Yes. Sorry?
Why is it 0.75?
Why is it?
Why is it 0.75?
Where is the 0.75 from?
Why is it 0.75?
Sorry, I can't catch you.
Why is it 0.76?
Oh, why is it minus? Okay. So, it is negative because our rope is being pulled back. It's getting shorter. Okay. So we recognize that when it's getting shorter, it's decreasing. So we put it as negative. Okay. So our concept was that decreasing is negative, increasing will be positive. Okay. Any other questions? Okay, so whenever you deal with connected rates of change, right, the challenge number one is to form out the equation. Okay, second challenge is always to figure out this statement. Alright, and third challenge is to figure out from the information that you have, you need to recognize. Okay, so let's just do one more question. Then you tell me what do you recognize from it. Okay. Okay, looking at question 14 in your exercise 13.4, that's on your textbook page 43. Okay, I know my drawing is not the best, that's why I'm over here teaching you maths. Okay, this is the best I can imagine of a lamppost and a man that's 2 meters tall, which is ridiculous. How can anyone be so tall? Okay. Yeah, okay, can. But I've never met a man that's so tall so far. Okay. Anyway, right, so it says that there is a man who is 2 meters tall walking away from the street lamp. Okay, so we add it into the diagram, walking away. Okay, then from a street lamp that is of a height 7 meters tall. Okay, and it is walking away at this particular rate of 5/3 meter per second. Okay. Question also went on to say that given that the top of the man's shadow is X meters away, so because if you understand how shadow is casted, okay, if you're standing here and then the light is there, my shadow is casted onto the whiteboard. So the lamp is here, the man is here, shadow will be here. Okay, so try to imagine that. So the shadow is here. So the top of the shadow, that means where the head is being formed, is X meters away from the lamp. Alright? And that is when he is Y meters away from the lamp. So if he is Y meters away, the shadow is X meters away. Okay? So variables are in fact already given to you. Alright? Question in part I asks you to express Y in terms of X. And then in part 2, they ask you to find the rate at which top of the man's shadow is moving. Okay? So let's try to figure out what part 2 is talking about first before we embark on part I. So find the rate at which the top of the man's shadow is actually moving. So this man is not starting at this part here. Okay, he started walking from the lamp itself and then walked towards here. So the distance is from 0 and then after that all the way here. So the shadow itself, okay, will just be getting further and further away as he walks further and further away from the lamp. Right? Okay, so we want to find the rate at which the top of the man's shadow, which maybe started here, and then after that moving. Okay, so what does this actually mean? We are looking at a rate, so surely it is something over dt. Okay, we are given y and x. Right? So are we talking about dx over dt or dy over dt? What do you think? Okay? Let's show a raise of hands up. Okay? So who thinks that it's dy over dt that we are trying to find? Who thinks that it's dx over dt? Okay, who's unsure? Alright, okay, it's fair that you're unsure. So we take the idea from top of the man's shadow is moving. So we define, okay, in the textbook itself, I didn't write it out, that x meters is the distance from the top of the man's shadow to the lamp. We want to see that this distance moving, this point over here moving away. So actually, we are trying to find dx over dt. Okay, understand? Alright? So now, okay, we go into part I. Okay, we want to have y in terms of x. Alright? What is the first thought that comes into your mind when you want to draw a relationship between y and x? What will you be thinking? Any suggestions? Yes, Bobby? Use similar triangles. Okay, anybody else has other suggestions or other ideas? So Bobby suggested using similar triangles. Anybody thinking of Pythagoras theorem? Anybody thinking of just taking x minus y equals to something? Nothing wrong. You laugh. Slightly later exam you also like that. Okay. Alright. I think these are actually fair thoughts that you have. Okay. That maybe you see right angle triangle, you try to think of Pythagoras theorem. Okay. But why is it that Pythagoras theorem will not work? Because you do not know this distance. Okay. You do not know any information about this length here. You only know the information here. Okay. And yet you want to draw a relationship between these two. Okay, which is actually parallel to each other. So Pythagoras theorem is out of the discussion. Okay, so you need to have this understanding of process of elimination. Okay, so it's actually fair to think of Pythagoras theorem because of right angle triangle, but it will not work. Okay, it is also fair to think of y and x. Okay, some difference minus something then become this distance. But the problem is we also don't know what is this distance. Okay, and so we can't actually make use of that kind of linear equation where y minus x is equals to something. Alright, so okay, let's look at similar triangles. Okay, where are the similar triangles? Alright, so earlier I mentioned about right angle triangles. Okay, we recognize that there is a right angle triangle and the big one over here. So if I were to draw it out with this red marker, so we got one big right angle triangle over here. Okay, so let me just take that out. And then we have another right angle triangle that is found at where the man is standing to here. Okay? Why? I cut the man in half. Okay, so we have another right angle triangle over here. So let's put in the information that we get. Okay? So from the big one, we have this 7 meters here. And this length here will be x meters. Right? Okay, the man will forever be 2 meters tall, regardless of what position is he actually at. Right, be it here, here, or whatever. Man is always 2 meters tall. Okay, then after that, this distance, since we want to, for similar triangles, we want corresponding sides. So we need to know what is this, and that is actually x minus y. Okay. We still do not know what is the hypotenuse. Okay, and there's no way for us to find out. But at least we have pairs being formed from corresponding sides. Okay, so with that, from similar triangles, right? Okay, corresponding sides ratio. Okay, so 7 meter and 2 meter is one pair. X meter, x minus 1 meters is another pair. The ratio will be equal. Okay, I just want you to bear in mind, it is not correct to think of 7 over x equals to 2 over x minus 1. Okay, Reason because in similar triangle concept, the idea is that ratio of corresponding sides are equal. So this is the property of your similar triangles. Okay, so the ratio meaning the fraction itself of the corresponding sides. Okay, and then they are equal. So then moving on, okay, we want to express y in terms of x. So with this fraction, we cross multiply. So 7 times x minus y equals 2x. We see that y is equals to 5 over 7x. So with that, our part I is done. Then we do our part 2. Okay? Alright, part 2 we want to find out what is dx over dt. Okay? Since I already have my y and x, I know how to get my dy over dx. So I'll just write down loosely. Okay, what is it that we already have? Dy over dx and dx over dt. These are things that we already know. We figured out. Okay, in the sense that dx over dt is what we want to find out. Okay, dy over dx we can derive it. Okay, so what is the missing part? What is the missing component for your equation using your chain rule? Dy over dt, right? So we need a dy over dt. Okay. So coincidentally, dy over dt is equals to dy over dx times dx over dt. Alright? So this one is what we want to find. Okay? Dy over dx we can find. Dy over dt we need to know. Okay? So where am I going to get my dy over dt from? The rate that the man is walking away, right? Okay? So let's say why is it that 5 over 3 is dy over dt? It is because the rate that the man is walking away, so you walk from here to here, right? Okay, it is that the distance, y meters, it is slowly increasing. Okay, so y meters is increasing against time. So it is actually the speed. So dy over dt is by 5 over 3. Okay, so now let's piece everything together. We have to find our dy over dx, which is 5 over 7. Okay, so dy over dt is equals to dy over dx times dx over dt. This is 5 over 3. Okay, by the way, the man is walking away, so the distance is increasing, so that's why it's a positive number. So dy over dx is 5 over 7 times dx over dt. And our dx over dt will be 5 over 3 divided by 5 over 7. So that gives us 7 over 3. That is 2 and 1/3. Okay, so therefore, the man's shadow, please remember to write your concluding statement. The man's shadow is moving at a rate of 2 and 1/3 meter per second away from the lamp. To be precise, the top of the man's shadow. Okay? Questions? Alright, so 13.4, got homework. Okay, looking at question 3, 4, 9, 10 and 11. Yesterday I gave your E-maths homework, right? That is exercise 3B, right? 3B. Oh, okay. That one I gave it to be due on Friday. Okay, Friday. So this one, even week, due when? Thursday is your A-maths WA. Before your WA? After your WA? After? Okay. Right? I'm okay with that. Odd week. Week 9, Wednesday. So more than enough time. But, of course, before your A-maths WA, I still got lesson with you on Monday and Tuesday. So I'll teach 14.1. I think 14.1, 14.2 maybe. So homework may come. So that means week 9 we got a lot of homework due. Okay? So, due 3rd March. Alright, and here, thank you everyone.